Hi everyone, welcome to lesson 5, which is on Bohr diagrams. If you remember, when we were talking about atomic theory, we looked at Bohr diagrams which looked kind of like models of the solar system, except instead of planets, we had electrons rotating around the nucleus. Now, while that model doesn't hold true as an acceptable picture of exactly what an atom looks like today, it does, however, capture some of the most important parts about the leveling of electrons into specific energy levels. So what we're going to do today is to practice putting electrons into energy levels based on Bohr diagram models. So as you can read above, it says Bohr diagrams depict the total number of electrons in each energy level and allow us to easily identify the number of valence electrons, which again will be the electrons in the outermost energy level. So we have two examples up here. We have tin and we have nickel. So the very first thing that is important to recognize is that when you're doing these problems, you have to be able to write the electron configuration, because organizing electrons into their individual energy levels can be done easily once you have identify the electron configuration for that atom. So we're going to do that first for tin. So for tin, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p2. The next thing that you're going to want to do is identify the number of electrons in each energy level. So to do that, you must first identify each of the energy levels. So in the first energy level, which is everything with a 1 in front of it, which is only this right here, we have 2 electrons. So in the first energy level, we're going to write 2 electrons. In the second energy level, that's everything with a 2 out in front. We're going to group these two together. So we have 8 electrons in the second energy level. In the third energy level, that's everything with a 3 out in front. So it's easy to spot these two because they're right next to each other, but we also have to group in there this 3d10. So we have 2 plus 6 plus 10, or a total of 18 electrons in the third energy level. In the fourth energy level, that's everything with a 4 out in front. So we have 4s2, 4p6, and 4d10. We have 2 plus 6 plus 10, so another energy level with 18 electrons. And then finally, in our last energy level, which is everything with a 5 out in front, we have 2 plus 2, or 4 electrons. Let's take a look at our second example. So in our second example, we have nickel. Nickel is in the 3D sublevel. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. So following a similar pattern, in the first energy level, we have 2 electrons. In the second energy level, that's both of these, we have a total of 8 electrons. In the third energy level, which is the 3s2, the 3p6, and the 3d8, we have a total of 2 plus 6 plus 8, or 16 electrons. And then finally, in the fourth energy level, we have just 2 electrons. Now, when I made the homework assignment for this lesson, it was very difficult to edit the picture with all of these semicircles that were in there. So instead, what I'm asking you to do is to just identify the number of electrons in each energy level on the side here. So for the first energy level, we have 2 electrons. For the second energy level, we have 8 electrons. The third energy level, we have 18 again. And then for the last energy level, the fifth energy level, we have 4 electrons. For nickel, we have something similar. So we have 2 electrons in the first energy level. We have 8 electrons in the second energy level. We have 16 electrons in the third energy level. And then finally, 2 electrons in the fourth energy level. Let's try a third example. So we're going to look at the element bromine. First thing that we want to do again is write out the electron configuration for bromine. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Now, grouping the electrons together by energy level. This time I'm not going to even write them in the Bohr diagram. I'm just going to list them down here. So in the first energy level, we have a total of 2 electrons. In the second energy level, which is anything with a 2 out in front of it, we have a total of 8 electrons. In the third energy level, which is anything with a 3 out in front, we have 2 plus 6 plus 10, or 18 electrons. And then finally, in the fourth energy level, we have just these 2, so we have 7 electrons. Let's take a look at aluminum. So for aluminum, we have 1s2, 2s2, 2p6, 3s2, 3p1, so it's a much smaller atom. In the first energy level, we have just 2 electrons. In the second energy level, we have a total of 8 electrons. And then in the third energy level, everything with a 3 out in front, we have a total of 3 electrons. Please remember, the electrons in the outermost energy level are known as valence electrons. So for aluminum, we have 3 valence electrons. And for bromine, we have 7 valence electrons. When we look at the number of valence electrons, we need to be able to determine what their most likely charge would be. So let's go back and look at our first 2 examples. So for tin, we have 4 electrons in our outermost level. Well, tin is a metal. Metals like to lose electrons. So the most likely charge for tin would be if it lost all 4 of these electrons. So we gain a positive 4 or 4 plus charge. For nickel, nickel has 2 electrons in its outermost level. Nickel is also a metal, so it will lose electrons. Therefore, the most likely charge for nickel would be a positive 2 or 2 positive based on the loss of those 2 valence electrons. When we look at nonmetals, remember that they do the opposite. Nonmetals gain electrons in order to get closer to that octet, that 8 electron outermost level. So if we look at an example of bromine, which has 7 electrons in its outermost level, bromine is going to gain an electron, so its most likely charge would be a -1, because in order to have 8 electrons in its outermost energy level, it must gain 1 electron. If we look at aluminum, aluminum is a metal. Aluminum has 3 electrons in its outermost level. A reminder that metals like to lose electrons. So aluminum will lose 3 electrons and end up with a most likely charge of 3 plus or positive 3. All right, I hope everyone has a great week. And if you have any questions, please reach out through Schoology Messenger or through email. Thanks, everyone.